Good morning. My name is Ariani Guerra.
My name is Jennifer Lopez.
My name is Joseph Cortares.
My name is Ricardo Ortega.
And my name is Esmeralda Fernandez.
Before we dive into the specifics of the La Brea tar pits, let's talk about the history of it. The pits are a group of natural asphalt or tar pits which are located in the heart of Los Angeles. They have been an important paleontological site for over a century. They formed around 50,000 years ago during the last ice age when oil and natural gas seepage from underground deposits bubbled up to the surface, which created sticky asphalt pools. Over thousands of years, these pits trapped and also preserved the remains of animals which became stuck in the sticky asphalt. These animals included mammoths, saber-toothed cats, direwolves, ground sloths, and many more extinct species, and also possibly a Native American woman who can be known as the La Brea woman. We assume it could be a Native American woman because we know that Native Americans used the asphalt as glue for their baskets and canoes. The Portola expedition in 1769 was the first recorded expedition, but it wasn't until 1875 that Professor William Denton found animal remains which he figured were fossils. The fossils weren't famous until 1908, where J.C. Merriam wrote an article, Death Trapped of the Ages.
Now that we have talked about the history of the tar pits, let's talk about how it was formed. The tar pits have slowly formed from more than 40,000 years and spreads more than just what is shown in the museum itself. The most famous pit is Pit 91, and so many fossils have been found here, even though it is only about 15 feet deep. Funny enough, the La Brea tar pits are not composed of tar. Rather, it is made of tar-like substance that is mostly comprised of asphalt. The asphalt can still be seen to bubble when you look at it today. This asphalt is very similar in its density and composition to that of tar. To trap its victims, it is extremely sticky, and not only that, it is also very hot. The asphalt, because of how sticky it is, traps its prey, and because of the heat it emits, it makes it really uncomfortable for the prey, who will burn while they are stuck in the pits and eventually die from the heat or being fully submerged in the pit. However, there were times when the tar was too dense, where the prey would sink in not fast enough, to the point where the prey was left for extended periods of time that could last days, and that would eventually die of sheer starvation. La Brea tar pits is actually asphalt, low grade of crude oil. The asphalt is left over after the crude oil's elements have evaporated. The odor of the asphalt smells like rotten egg. Odor is hydrogen sulfide. The smell comes from the natural breakdown of hydrocarbon molecules in crude oil. The bubbles in the asphalt are methane. It forms from crude oil when marine organisms break down because of heat and pressure.
In the asphalt, we are able to find many different types of fossils from the animals that have laid to rest there. These animals have gotten stuck because they either got stuck in it in the first place and couldn't get out, or were then eaten by predators that came around them. The tar pits, or the asphalt pits if you would, became a huge feeding ground for the animals around the area. The surrounding area had predators and prey like any other environment. However, the prey would usually get stuck in the asphalt and the predators would come to hunt them. However, the tables have turned on the predators because sometimes as they were hunting, they would fall victim to the tar pits and eventually would become prey. There are so many fossils that are found in the tar pits and all over the museum. However, there have been one just very significant fossil that has been found in the La Brea tar pits. This fossil is the La Brea woman, as previously stated by Ari in their introduction. She was found in 1914, and to be more exact on what was found was a human skull and a partial skeleton that seemed to belong to a woman. This woman, due to what we believe the area around it, is believed to be a Native American woman. There is a sketch provided in the next slide. However, there is not sufficient evidence to say specifically how she died, where she died, or how even her body ended up in the pits. It still remains a mystery to this day. However, in order to understand these fossils and understand the timeline, these fossils must be thoroughly cleaned out of any imperfections that are found. Upon further inspection, an archaeologist may find a fossil and then want to clean it. But how do they clean off the sticky gunk and the tar that is left on top of it? What was cool is that they actually showed us this in the museum. They have a segment in the museum where they have people working in front of you, cleaning up the fossils and dating them in real time. They are only able to do this if the fossils are clean themselves. To do this, they have to have a chemical solvent that is used in order to break down the composition of the gunk of asphalt or tar. They use Novik 73DE, which is a heavy-duty solvent that is used to clean various items, especially fossils. It is usually used as a replacement for N-propyl bromide, and it is a great way to remove heavy greases, oils, waxes, silicones, and non-polar flux residues. It is also a substance that is non-flammable, which makes it safe to use for everybody, especially for those working in the lab who are trying to find an exact date for when these fossils were found.
The sedimentation process at the La Brea tar pits is something that has been ongoing for thousands of years, which has resulted in the protection of numerous fossils, and it all begins with the natural leakage of asphalt and a dense form of petroleum as well, which emerges from underground petroleum deposits. This asphalt is rich in hydrocarbons and has a thick, sticky consistency. When it comes to the correlation between sedimentation and tar formation, it's often observed in environments where organic material is conditioned and conductive to the preservation of that organic material. When organic materials such as leaves, twigs, or animal corpse come into contact with the tar, they often become trapped in the leakage, as you can see here in the slide. Over time, more and more organic material accumulates, which forms layers within the tar. As these layers have built up and the weight of the overlying material compresses the lower layers, they expel water and they also trap gases. This compression process, combined with the chemical properties of the asphalt, gradually transforms it into a dense and semi-solid substance as well.
The possibilities of a volcano forming in Los Angeles. Los Angeles is situated along the western coast of the United States, within the broader tectonic setting of the Pacific Plate boundary. This basically means that the Earth's plates meet near the Pacific Ocean. Most volcanic activity is predominantly associated with divergent and convergent plant boundaries. This basically means that most of the volcanic activity happens where the tectonic plates are moving apart, which this is divergent boundaries, or coming together, convergent boundaries. Let's go into more detail. So divergent boundaries, these occur when tectonic plates move apart, allowing magma from the mantle to rise and create new crust. Example of this includes the Mid-Atlantic Ridge and the East Pacific Rise. Convergent boundaries. This happens when tectonic plates crash into each other. When an ocean plate goes under a continental plate, it can create volcanoes through a process called subduction. The Pacific Ring of Fire is a famous example of convergent plate boundaries with lots of volcanoes. Los Angeles is not located near any divergent or convergent boundaries, so volcanic activity related to this type of plant movement is not expected in the region. Los Angeles is located on the overriding North American plate, far from any active subduction zone. To summarize this, Los Angeles' geological setting, characterized by its position along a transformed plate boundary and its distance from active volcanic zones, makes the occurrence of volcano activity highly unlikely. Volcanic eruptions are more commonly associated with areas located near divergent or convergent plant boundaries, where the conditions for magma generation and ascent are favorable. So therefore, the movie that was created was more fictional than anything, and kind of hard for a volcano to erupt in Los Angeles like the movie
thank you for watching our presentation of the La Brea tar pits. We hope you had as much fun as we did learning about the subject, and hopefully you guys get the opportunity to visit the tar pits and see for yourself. Thank you again. Bye!